So here it will be unit 2. I think this one will be lesson 5. You can put the date and the hour, and it will be kinematics. Kinematics. For kinematics, it is the motion, accelerated motion. Okay. For kinematics, we have some formulas that we have to use. Okay. Say I have an object. If I have an object and I want to study them in point of view of kinematics, so what information I have to do, because I'm studying the motion. I'm not studying the object. I don't care about the object. I'm studying its motion. So this object can be a car, a toy. It can be anything. When we are studying kinematics and motion, the first thing that I must have, it is displacement. Where is it? So the first, so right here, variables. So what are variables for a motion? Variables of a motion. I'm going to put it here, of a motion. The first variable, it is delta D. This one, it is displacement. Displacement. Then I have V1. It is a vector also. It is the velocity, initial velocity. Initial velocity. Initial velocity. V2, final velocity. Delta T, time between the initial and the final, between the situation one. And we have A, acceleration.
So
acceleration.
The first one is initial, and then this
yeah,
final.
It is the final. We call it V1 and V2. You can call it VI and V final, but we're going to use V1 and V2. It is V final. So what are the units? The displacements will be measured with meters. The velocity will be measured with meters per second. This one, meter per second. The time will measure it with seconds, and acceleration with meter per second squared. By looking at the units, you have to know it is what? Displacement, velocity, time, or acceleration. Okay, so this is what I can learn about the motion of an object. A motion of an object, I have to know is the displacement, the velocity, the initial velocity, the final, the time, and the acceleration. That's it. I don't care about the object, if it is a car, if it is a train, a plane, or anything, or simple objects yourself that you are moving. Okay, and here we have some more formulas. Formula. So we have some formula. The first formula, it is, I'm going to give it to you here, delta D equal V1 delta T plus a half A delta T squared. The second formula, it is V2 equal V1 plus A delta T. The third formula, it is delta D equal V1 plus V2 half V1 plus V2 delta T. The fourth formula, it is V2 squared equal V1 squared plus 2A delta D. Okay, this is our formula that we're going to always to use with kinematics. When I'm studying a motion of an object, what is a motion? For example, I'm looking for the velocity. This is a motion. I'm looking for displacements. So if I know 3 of these ones, I can find everything else. Are you okay now? So we're going to put here important or note. I'm going to put a note here. So put it note. If I know three of these variables, I can find the others. Always you have to have three, at least three information. If you have only two, it is not sufficient. Okay? So, we must have at least three variables. Okay? At least you must have three variables to. Can you shut door, please? Okay? At least three variables that you can find the other ones. Are you okay now? So now we're going to do the exercise. What the exercise is saying, give me the page. Here what they are saying. A boy in a wagon starts from a rest position and then goes down a straight ramp, gaining speed with uniform acceleration as he travels. In 6 seconds, he is traveling at 4.2 meters per second. What is his velocity? So what they are saying here, so I'm going to write an example. We have a boy that he is taking a ramp like this one here. He is in a wagon. Okay? Yeah, a wagon. I'm going to put a box. A wagon. He starts from here. He's playing. He is here. And he's sliding. Okay? This is what they said. They slide in. And he gave us some information. This is the ramp. He's enjoying himself. He's sliding. Are you okay? Now what are, because this is a motion, kinematic. So what are the variables? Delta D. What are the variables? Give it to me. V1, V2, delta T, and acceleration A. So what information they are giving us? So we're going to read the sentences one by one. And we're going to try. A boy in a wagon starts from a rest position. What does it mean, rest position? Starts from a rest position. Start, it is initial because it starts. What does it mean, rest position? For the variables here, what does it mean? Okay, repeat again. V1, it is what? What is its value? It is a rest. It was at rest position. Rest position. What does it mean? It is moving. Is not moving. If it is not moving, what is the 0 meter per second? So they give us V1, the initial. V1, it is 0 meter per second. What they give us again? They say then goes down a straight ramp, gaining speed with uniform acceleration. So the acceleration, it is uniform. We know that there is acceleration. Uniform. Uniform. What does it mean, uniform? Uniform, that means doesn't change. So the acceleration doesn't change at all. So what we have else? What they are giving us? It travels. Excuse me. They give us the time. What is the time? 6.0 seconds. 0, 0 seconds. They give us. Yeah. Yeah. At 6 seconds, the V2, it is what? 4.2 meter per second. So what is question A?
What is the velocity at 10 seconds?
Good. What is the velocity at 10 seconds? What we are looking for? At 10 seconds, 10.0 second, which we are looking for, which velocity, V1 or V2? V1, it is initial, it doesn't change.
Okay,
We are looking for V2, the final, we are looking for V2. So how are we going to find it? What is the difference between this time and the time? Here they give us 2 times. Can you tell me what is the difference between 6 seconds here and 10 seconds? Because 6 seconds, which each velocity. Excuse me? No, there's nothing there. Look, the 6 seconds here, it is 4.2 meters per second. At 6 seconds, he was at 4 meters per second. This velocity here. For this 10.0, we want to find what will be another velocity. So what we can do with this one, what we can find with this this information here, you can use this formula to find what? V2, we know it here. For this situation, we have here the acceleration. So this is what we are going to write. So I'm going to write it here. Find the acceleration. Find the A. So I'm going to find the A. I'm going to use which formula? I'm going to use the. Did I raise them? No. I'm going to which formula? This one. 1, 2, 3, 4. I am going to use the second. Why? Because I know V2, I know V1, I know the time. So there is only one thing that I don't know. It is A, so I'm going to solve it. It is a grade 9 solving. So I'm going to write it V2 equal V1 plus A delta T. I plug the numbers. What is V2? It is 4.2 meter per second equal V1. What is V1? 0 meter per second plus A times delta T. What is delta T? 0.00 seconds. Okay? And I have to solve for math. There is no calculation here to do. So 0 here, yeah. So I'm going to bring it to the other side. This 0, it will be minus 0. I'm going to bring this 0 here. By minus 0, it will stay the same. 4.2 meter per second equal A times 6.00 seconds. You have to bring it other side. What you're going to do to bring it the other side? Yeah, by division. What you're going to divide? Good. 4.2 meter per second divided by 6.00 seconds. Why I am dividing? Because I have multiplication. Multiplication, the contrary of multiplication is division. And I will have A here. So 4.0 give you 0. What? 0.7 meter per second. So I have two digits. I'm going to keep another 0 here. Meter per second square equal A. And since A it is a vector, I'm going to write it here forward. Okay. So here the acceleration it is 0.70 meter per second squared along the ramp. Ramp forward along the ramp. This is the direction. The direction it is the direction of the ramp. So I found the acceleration. So what I have to do to answer the question now? Okay, so I get some information. Find the velocity. So I'm going to write again delta D V1 because for the first situation here it gives me the acceleration. Now I have to answer the question because they changed the time. Understand? They changed the time. So I'm going to write again my formulas V1 V2 delta T and A. A will not change because it is uniform. The acceleration doesn't change. 0.70 meter per second squared. Delta D, we don't know it's what is it. V1, does V1 will change? No, because the initial velocity, so it will not change. 0 meter per second. V2, does V2 will change? Yeah, V2 will change. The time changed, yeah. So we are later. 10.0 meter second.
The time is 10
seconds, and you are going to find V2. Yes, it will be the same because we have everything. So I'm going to write it here. Find V2. Which fourth formula? Which formula you're going to use? Yeah, which formula you're going to use? Yeah, the same. Yeah, the same. Why? Because this equation here, the second equation, I know A, I know delta T, I know V1. So I'm going to calculate V2 simply. Okay? So I'm going to write V2 equal V1 plus A delta T. V2, it is what? This is what I'm looking for. V1 equals 0 meter per second plus the A equal what? 0.70 meter per second square times delta T it is 10.0 seconds. And V2 equal, yes, if I make the calculation, it will be give me 7.0 meter per second. 7, but I have to put it .0 because I have two digits. So V2 here, the answer, V2 equal 7.0 meter per second. And since it is a vector, I have to give the direction. The direction of what? Of the ramp. No, it can't be north because we don't know the ramp. What is the direction of the ramp? He is sliding on the ramp. So it will be the direction of ramp. You can't say direction of the ramp. You write ramp here and that's it. because they didn't give us the information, the direction of the ramp, what is the angle, we don't know it. So I'm going to write ramp. Okay, so this is for this first question. What about the second question?
How long will it take to reach a speed of 228 meters per second?
Okay, so now they change it every 10 again. Since they change it every 10, what I'm going to do also so I'm going to write, yeah. So what is the question B now?
How long will it take?
How long it will take? How long? They are looking for delta t, yeah. And what is the information that we have? I'm going to write again my variables, delta d, v1, v2, delta t, and a. Does a will change? Look here. A will not change. 0.70 meter per second square. Does v1 will change? No. 0 meter per second.
The V2.
V2, yes. What is V2?
V2 is 28.
Yeah, they gave it to us. What is V2? 28.0. They gave it to us. 22.0 meter per second. And we are looking now for delta t. Okay. So which formula we are to use? The same formula again. So we're going to write V2. So here, V2 equal V1 plus A delta T. V2, we know it. It is what? 28.0 meter per second. V1, we know it. What is V1? 0 meter per second. Plus the A. What is the A? 0.7 meter per second square times delta T. And we have to solve. What I'm going to do, bring this one in the other side. 0, so it will be minus 0 minus 0. It will be 28.0 meter per second equals 0.7 meter per second square times delta t.
Then you bring it over.
So what I'm going to do,
28.
yeah, so what operation I have to do? I have to divide because I have multiplication here. I will divide by 0.7 meter per second squared. I will divide by 0.7 meter squared. And then I'm going to continue 40. Good. I'm going to continue here. So delta t, it gives you, what gives you? 40 seconds. Okay. And this is, I have 2 digits. This is 70, 70. I have 72 digits. I'm going to put a dot here. So delta t equal 40 seconds. Okay. You see how we do exercises like this ones? It is only you have to put your variables, read carefully the situation, and put the numbers from to, and you catch or you determine the formula that you have to use. Always you have to use the formula where there is only one thing that you don't know, but there is something. You have to know 3 things that you can solve the problem. Otherwise, you have some information that you didn't catch. Okay, so I'm going to stop the video here. Good.